For everybody who's new here, I guess I just explained to you that there is the possibility of asking questions. Just use the Q&A tool from Zoom, put your questions in the chat, and then we will moderate the questions after each talk. And with that said, I guess we can just start in right away into the talk from Julia. She's a business development lead at Hyperloop. She has had her eyes on Hyperloop for a longer time now as the business manager for innovation in Rotterdam. And how Hart now just located there, I wouldn't say that's a coincidence. And I always like to see it that somebody is following Hyperloop for so long from the sidelines, from outside of the Hyperloop industry itself, and then joins in as well. So it's very good to have you, Julia, and you can start sharing your screen and start with your presentations.
Yes, thank you very much, Lucas. I will start sharing. Yeah, you just gave the introduction already. So my name is Julia Ommens Meer. I'm business development lead, especially on Europe for Hart Hyperloop. And I'm with Hart now for about 8 months, almost 9 months now. Yeah, but I've been with seeing Hart since the start, looking at Hart in the area since they started like 7 years ago. So I've been close by, but always been a little further away because not been involved in the Hyperloop technology before. But what I would like to share with you today is a little bit more about creating a hyper-connected Europe, how we do that together with the Hyperloop development program and with Hart, from here, how we try to convince cities, regions, and other stakeholders to work with us and realize Hyperloop together. That's actually what I wanted to take you with me today. I know a lot of talks are always more on the technology side, so this is more on the business development sales side. So I hope, I can bring a little bit new stuff to you. Well, this might not be new for everybody. Last year, there was a study done also by HDP about the potential for a network scenario in Europe. Actually, this map came out of the study that was done, and it's supposed to be a network where enough capacity will be built up with Hyperloop to connect all European countries, but also to be able to offer a good alternative for continental flying in the future. That is, I think, where we are looking at the most, especially on the passenger side, to build up a real sustainable alternative for continental flying. And then this network of about 25,000 kilometers is what is a necessary minimum scenario to cover or to generate that alternative. That study has been done already. But the thing is always like, how do you start and with whom do you start? Because it's a big network, 25,000 kilometers, and you have to go from somewhere. So what we've done is we've gathered a lot of support from cities and regions in Europe. In the beginning, it was spread quite a lot. Nowadays, we have a big pile in the Benelux region, which is not a coincidence. That's absolutely where we are located as well, in Rotterdam. And we have, beginning of this year, done a really big reach out in that region as well. And there's more and more cities and regions that want to support Hyperloop. Actually, it's many more than those dots that are here right now. Those cities and regions have already signed a letter of support, but there are many more to come. So I think Hyperloop, in general, interest is only growing. So that is really good. But like I said, where do you really start? If you want to work with the market and look at the market, like what route could be a first route or whatever, you have to start somewhere. And the best thing is if you can base it also on data. So that's what one of our colleagues has done as well. Looked at especially passenger data, also from flight industry again, but also looking additionally on cargo streams and road transport for passengers and goods. And well, it's not surprising that, again, this area is one of the busiest areas in in Europe. That's actually the axis between London, Paris, and the Ruhrgebiet in Germany, in the western part of Germany. It's the highest travel volumes. It's also most densely populated area in Europe. It's a huge and major industrial area. And yeah, like I just said, it's combining all these big cities. It's in between all those big cities where a lot is happening. And if you look at it even further, and that's also why we came with this idea, it's also, I just said, a big industrial area, but there is the industrial area of Wallonia. There's the industrial, the diamond area, they say, in Flanders, in the north of Belgium. You have the Randstad, which is the biggest industrial area in the Netherlands. And then you have the whole North Rhine-Westphalia, the Ruhr area and Rhine area in Germany. So those are big industrial areas. And if you look at this map as well, you can see that there is, in terms of high-speed rail, there's already something existing. But most of those connections are north-south connections. So from London via Lille to Paris, you have the connection from Amsterdam, Rotterdam, Antwerp, Brussels. And then in Germany, you have a connection between Cologne and Frankfurt, high-speed rail, and a little bit more to the north. But what is not existing, actually really not existing, is east-west connections in terms of high-speed rail. And if we are looking at new route developments, we don't want to be competitive with existing rail or high-speed rail, but we want to be complementary. And then we thought this might be a really good route or really good area to start with the first network vision for Europe. Actually, to upgrade the existing public transport network. That is the idea that we're having. Well, this is the idea that we came up with. It's actually, we call it the Hyperloop. It's only a working title. It's just because it's that first possible European network scenario. And we came up with two different potential routes connecting the same areas, but via two different routes. And why is that? Well, Belgium, as you might know, we have the Flanders side, which is the more northern side, and the Wallonia side. And we just thought it's good to have both on board, but to see if those routes could be existing next to each other, or and could be complementary, or if it would be one or the other route that could be built. And we thought it would be good to at least look and study both of these routes and see what might have the highest potential for the future. So yeah, if you look at, well, what we did, we came up with this idea. We came up with this route idea, but we thought, okay, we have to engage with all those cities along the route to see if they are interested at all in Hyperloop and if they would see this as a potential network for the future. So we did. We actually engaged with all these cities. We sent out mailings, and we never thought we would get such good reaction, but we had more than 80% reaction of all the cities. We had discussions with all of them, and they were actually all positive about it. But then when it comes down to really doing a study, then it always gets a little bit more complicated. But actually, right now, we're in really good discussion with the city of Bruges, Ghent, Antwerp, and Turnhout in Belgium, which is like a whole line here on the Belgium corridor on the Flanders side, and also with the state of Vlaanderen, with the national government, well, part of the national Belgian government, I have to say. And they are interested in looking into this Hyperloop and see what the economic impact can be, what the social impact can be, and how the whole area could get connected to the rest of Europe better. So that's how we approach this. That's how we try to gather cities together to look into such a route study. And actually, they're really interested. VEL is also a partner in this from the logistics side in Flanders. They were an early supporter of Hyperloop as well. And I hope we will have a study up and running beginning of next year that we can provide to them. And actually, I didn't have that in this presentation yet because it just came up yesterday, but we're also now talking to Limburg and Aachen in Germany, together with a connection to Liège in Wallonia, to provide another study. And that one will already be signed next week. So some things are getting quicker than others. But it's really interesting to see that we came up with this idea, and those cities, they like it. They would like to look further and see if there's really potential in it for the future, and really for them to connect to the rest of Europe. And I think that's the really interesting part of it. If you start with an idea like this, that it really takes up shape. But the other way that we're also looking at it is not only involving cities and regions, but we also try to involve rail operators and infrastructure providers. Because if we look at the whole network of Europe, then they are probably the parties that we have to work and collaborate together most. They sometimes still see us as competitors. And we have to convince them that we don't have any, how do you say it, that we don't want to be their competitors. We really want to be partners to actually make this, to make the Hyperloop happen. And with everything that we do in development for Hyperloop right now, we're actually trying to provide them with a new business model that they can use to innovate their own system, to innovate more transports, their own transport system, from only rail to hopefully rail and Hyperloop in the future. And well, even there, we also started close by. We started in the Netherlands. We started with NS and ProRail, NS being the operator and ProRail being the infrastructure provider in the Netherlands. And they were first really, really skeptical, ProRail at least. They were really skeptical and saw us really as a competitor. But when we started talking to them and had organized quite some sessions with them where they were open to, we said, well, let's do a study together of one route. You can see it here. It's actually it's one of the longest routes that's possible in the Netherlands because we're not that big, but all the way from Groningen in the north to Zeeland in the south, which is actually also a route where there is almost no existing rail infrastructure yet, only a really, really short part on the southern part in Zeeland. The rest, there is no parallel rail infrastructure existing yet. And we studied that. We studied that route with them, and we simulated with our own software. We've written, one of our colleagues have written on software to simulate this route and see how it can interact also with the existing trains and the rail operators. And the funny thing is that ProRail was so happy with the results that came out of there that they asked us to write a paper together. Actually, this paper has now been written and will be delivered or will be presented next week at the CVS Congress in Brussels. And ProRail is now one of our biggest supporters because they gave us this quote. And seeing Hyperloop as a transportation system that can be a game changer for mobility in the Netherlands, going from really skeptical to being really optimistic, that's actually what we're trying to achieve. And we started with the Netherlands, but we would like to do that everywhere in Europe. And we think that it's really important to do that together, not only us, not only HTP, but we would like to do that with the whole Hyperloop community together. So getting more in contact with cities, regions, but also railroads, rail operators and infrastructure managers is what we want to do. And I would like to invite everybody also in the call here today, if you have any connections and if you want to help, really happy to bring this further into Europe. Thank you very much.
Thank you very much, Julia. Thanks a lot for your good presentation. We've already got a few questions in the chat that I would like to ask to you. I think you can see the Q&A there as well. The first question that I have here, but yes. I'll read them to you anyway. The especially everybody, I think you can vote on the questions as well. So if there's more interesting ones, please vote some of them up if you like them more. I think we'll just start with the first one. Where did you get the logistics data in order to find the requirements of throughput for the network simulations that you've done, where you have bigger routes, smaller routes? Where do you actually get the data from? Is that airliners, rail?
Yes, we took mostly public available data. Actually, I would have to ask my colleagues exactly where they found the data, but it's they did the number crunching. I didn't do that myself, but I can check that. And also, I don't know if that's possible to also answer some of those questions afterwards. But like I said, it's publicly available data. I think nothing too fancy, and we did update it with data that we got from cities and regions that we work together with.
Mm-hmm. Then there's what is the business model that you foresee the difference in business model between Hyperloop and rail? Where's the difference for you?
Well, actually, I don't think it's really a difference. I think it's an add-on. It should be an add-on for especially infrastructure managers and rail operators to look into Hyperloop as an additional mode next to rail. I think it can be either adding like we did here with the Hyperloop to something that's not existing, like make new connections and connect high-speed rail with each other between different countries as well, cross-border. On the other side, what we see, for example, in the Netherlands, when we've done the study with ProRail, is also that they have a lot of problems especially in planning their different trains. They have high-speed rail, they have intercity, they have more regional lines, they have as we call it, stop trains, which is really stopping everywhere, and then they have cargo trains. They have all different speeds. They all go over the same rail network, the same infrastructure. And especially if you have a high-speed train going over the same infrastructure, it needs like half an hour to 45 minutes up front of free space, which then cuts down on all the other users, let's say it that way. So looking at bringing especially the high speed and the further distances, that capacity of passengers, bring that from the normal rail, put that into Hyperloop, especially where there is huge capacity needs, because the capacity of rail is already like full. And then there will be new room for more of the regional and local trains, and also for cargo trains, and getting more containers from the street to rail. That's actually what they are looking at with Hyperloop. So that's I think is the add-on to the business model.
Yeah, I think you're putting words into the same curve as, like, for example, Markus from Deutsche Bahn always says, when he says, like, if you replace one ICE, we can have 3 cargo trains on there.
Exactly.
I think same that you're pointing out here as well. Another question is looking also at high-speed trains at border crossing. Could it be more interesting to look into border crossing high-speed service, especially rail, for example, or something else? Because railways normally have different standards in different countries, and it might be more easy to do a new connection of Hyperloop there than just within a country itself.
Absolutely. I think what we're looking at in the Hyperloop as well, I mean, it's going from Lille through Belgium, through the Netherlands to Germany, so really crossing borders. Yes, sometimes we look more at a national system if that is wanted or if that is asked. But I think especially cross-border is interesting. And I think that's what we all want, getting one Hyperloop standard everywhere so that we can overcome those problems that rail has with different infrastructure in different countries. And I think that should be, it's the goal to have that European system really cross-border. But in the end, you have to start somewhere a little more local and regional, because you have to start building. And hopefully from 2030 on, we can start building in many countries at the same time, when all the certificates are there, and when everything is up and running, and the Hyperloop is really the fifth mode of transport that we all are looking for. But I think that, yeah, it's a fair question, but it should be over the border, but it can also be an add-on nationally.
Okay. Great. Then there's two questions looking at pricing and cost investment. The first one is how is the ticket pricing and how would it be more cost competitive compared to high-speed rail when coexisting?
Yeah.
And the second is the amount of investment that is computed for cities to need to invest into Hyperloop.
Okay. First, the first question. So in comparison to high-speed rail, we've done a study with Deutsche Bahn not so long ago, and there the Hyperloop came already out cheaper than high-speed rail. By then it was about 10%. We are now with new design changes and so on, we are at about 20% less costs right now. And it's our goal also with scaling up over the next 5 to 10 years, well, scaling up first starting and then scaling up, that our goal would be to be about 40%, 30 to 40% cheaper or lower in pricing. Cheaper always sounds cheap. Lower in pricing than high-speed rail. And I think then it really gets interesting for investors also to invest before that already. But I think it's getting more interesting the lower the price will be in the end in comparison to high-speed rail.
Yeah. Yes. And how does it work with the investments that needs to be done in cities and especially cities and the routes, and then also the investments into the infrastructure as well?
Yeah, well, we think there's quite a good business case of Hyperloop. If you look at the return of investment in terms of ticket pricing, well, we are not in charge of we will not be in charge of the operations later. That's one thing. So I think it needs to be regulated somehow. But on the other side, if you compare kilometer prices from rail and flying, and if you take those, I think those are about 15 cents per kilometer, something like that. And if you would put that on Hyperloop, then with a complete European system of about 25,000 kilometers, you would earn back the capex and the opex cost in about 6 years, which is, I think, quite good for a public transport system. But then even if you would make the prices cheaper, you would get those costs back faster. And I think this is so attractive also for investors from the private market, not even the public market, that I don't think that cities, regions, and governments will be the ones investing in this. But I think there is a fair chance that the private market will take over a lot of the investment costs if they can earn back some money, but also keep it for everybody to be used. It should be a system that is not only for rich people, but it's for everybody. So I think that's why it needs to be controlled as well by a government or Europe or whatever in terms of pricing. So it cannot just grow everywhere. And I think what's also important is that, why do we think this is the case? Because you have a hybrid system for passengers and for goods. So if you look at it, the capacity of the Hyperloop is huge. You can use it over day when there's a lot of people wanting to use Hyperloop and wanting to travel. But at night or when there's downtimes in terms of passenger travel, it can be used by cargo. And that makes it, I think, much more attractive in terms of costs, because the infrastructure can be used 24/7.
Someone else also asked a question with regard to the infrastructure and how do you plan to coexist with existing infrastructure, rail, high-speed rail, other public transport network systems? But I guess that's pretty quickly answered, right? For Hyperloop above or below?
Yeah, well, the idea would be to use existing hubs that can be airports, that can be rail stations, as far as possible. So to tap into the existing public transport hubs that are already there, connect those, either where there are no connections yet, or like we said, parallel to what's already existing, but where the capacity is already more than 100% used. Let's do it that way. And I think what's important is we try to put the Hyperloop, if we can, as much as possible, parallel to existing or in existing corridors that can be rail, but preferably probably even highways. And why is that the case? Because if we look into claiming new ground for a new infrastructure, then ground that has not been claimed yet or not been, let's say,
used in any other mode.
Yeah, that has not been reserved for any kind of infrastructure. That always takes 10 to 15 years, and we would like to avoid that. But for example, most of the highways that we have, they have normally already claimed land next to it because they've always planned on, or at least had in their mind, maybe they need extension of the highways. Well, let's hope that's not going to be the case, because this is not going to solve the problem. So what we think is that there would be plenty of space next to highways that is already reserved for infrastructure, and that could be, well, switched from use for highways to Hyperloop. That would be our ideal idea and scenario.
Perfect. Thanks a lot, Julia. You have left no questions unanswered. Thank you very much.
Thank you.
I think with that, we can head over to Daniel to introduce our next speaker.
Yes. Thanks, Lucas. Thanks, Julia, for the interesting talk. And now we have the pleasure to welcome Bauling from the University of Applied Sciences in Wallis in the south of Switzerland. She will be talking about a numerical model and the performance analysis for the 3-kilometer test track Eurotip is envisioning to build in the south of Switzerland. So there have been quite some findings on this regard. With this said, then, Bauling, I would leave the floor to you. We are really looking forward to the talk. Thanks for joining again.
Thanks for the introduction. And my name is Bauling. I'm a senior researcher associate at HESSO Wallis. Thanks for the Hyperloop seminar inviting me to present one of our collaboration project with the Eurotube Foundation. My presentation is more specific and technical regarding the Hyperloop electrification system. Julia, she gave a presentation more macro scope regarding the European level. So my presentation now become very specific technical specification. So actually this work I have published in the proceeding of PowerTech conference in this year. So I just uploaded the manuscript PDF in the question part. If you are interested, you could download this work directly. Maybe I think I could close. I don't know now. You could see all the I mean the videos of each other, because it had some part of the presentation from my part.
We do see both slides, both papers.
Okay. No. Oh no. Because from my side, because now we show one column for the videos with each other, then one. So maybe I change. Sorry, I changed the format.
There's no video right now.
I just maybe here. Yes, it feels good. Okay, now it's good. So my presentation mainly includes 4 parts. Firstly, I will give an introduction on the Eurotube Hyperloop concept. Then I will present how to build the numerical model of the electrification system for our Hyperloop system. Based on the built numeric model, I do some case study and performance analysis. Finally, in the end, I provide some conclusion as well, discuss some perspective in the future. So, Eurotube Foundation, they are planning to build some demonstration pilot for Hyperloop. As we know, the Hyperloop project is a multidisciplinary project involving multi-fields, for example, mechanical or civil engineering, electrical engineering. So for us, HESSO collaborate with the YouTube Foundation, focus on the pillar electrification system designing and configuration. We build the digital simulation model to test the possible conceptual Hyperloop realization, as well as determine some optimal configuration before the construction. This work, as we can see, actually here I show a figure. It's a simple presentation on the Hyperloop concept from YouTube. Actually, we have some capsule train accelerated in the launcher area. When they arrive at the destination, they will brake in the recuperator, and the same the inverse direction. They did the same behavior. And here for the acceleration area, and the accelerator area actually is supplied by some power supply system. Actually, we use some outer electrical system connected with some power electronics converters from AC to DC. Then we have the medium voltage DC network. And because here we use some linear machinery, so we also use the AC-DC converter to convert to DC source. And in the constant speed area, that means when the capsule arrives the maximum speed they require, they will keep a constant speed, and so now they will be supplied by the onboard battery. So for us, we focus on this launcher and recuperator area, and for the constant speed area, it's not in the scope. It's in my work. So for the numerical model, we mainly have two parts to model. The first part is the moving train model. Another part is the electrification network. Before building the train capsule traction system, we need to collect and make some assumption for the input data. Here we assume it has a maximum speed requirement around 250 per second. For the acceleration speed, 1 meter per second square. And finally, we consider for the pod, passenger pod, it has around 70 person maximum, and each person around 100 kilogram, including its luggage. So finally, the mass around weight around 26.6 ton, and the same as another assumption for the freight pod. And here, actually, all the parameters we collected, we try to consider the real case, real situation, but they are flexible to change, to test for different configuration. And another important input information is the speed and position profile for the train. So actually, we try to do some survey with the YouTube try to do some survey to calculate the daily demand for the per hour, how many launches we need for the capsule train. And so they evaluate the daily demand based on the current traffic by rail, by car, by plane within Switzerland on the Zurich to Geneva route. So that we can find actually they have some rush hour in the morning from 7 to 8 a.m. and some evening peak hour from the 16 to 18 o'clock. So actually, this is the most rushy hour and the critical condition for our electrification network. Then after collecting all the input data, actually we could build our train traction model we have the speed profile according to the daily demand. And then we could calculate the position profile of each capsule train, which position it is in real time. Then we can calculate based on the traction model to calculate the current profile of each train. So here I show some result. It's the capsule train speed profile, and here is the position profile. Then here the output is the current of each train, and here we have the train acceleration and the deceleration. So now we come to how to build the model electrification system. The traditional railway system could be configured to AC or as well to DC. So for the Hyperloop electrification system, we also have both possibility. And for us, actually, for the DC network, with the same voltage level, usually, because the resistance for DC network is lower, they have much lower power loss. So they have a higher efficiency. And another issue is the DC network. We don't have to do some like frequency synchronization as well as some reactive compensation. And another point, if we would like to integrate some, for example, PV renewable energy or electrical vehicle EV charger into the network with a DC network, it could work as an energetic hub. It's more convenient. So in this work, we choose the medium voltage DC network for our Hyperloop electrification system. Then how to build the electrification system with the moving train loads. As we know, the train loads are specific. They are not fixed. The consumption profile is changing all the time, as well as their position that connect with the electrification network. So what we could do is we could split up the transmission line into very small elements. I mean, you could cut per 100 meter or 20 meter. It depends your calculated precision as well the computation efficiency. Then we calculate the real-time position of each capsule. Then we could, when they move, we calculate the closest node. If it is connecting to this closest node, the load is the consumption power of the train. Otherwise, this node, the consumption power is 0. That means finally, we have a fixed electrification model, but we have the moving loads. To model the medium voltage DC electrification system, it could use the modified nodal analysis method. Actually, they need some input for the current source as well as the voltage source. Then we could calculate the matrix G. Actually, that's the small, we could use the resistance of each small element to calculate the matrix G. And for other, we could find the DTUs in this reference. And the output is the voltage of each node and the current of the voltage source. That means we could calculate the current for the substation and the voltage for each capsule train. So here we build the numeric model with the MATLAB Simulink software. Then we could choose to the simulation step is 1 second. Then with the built model, we could conduct some case study and performance analysis. Before the performance assessment, we need to choose some indicator to evaluate the performance. So the first indicator we choose is a voltage variation, because the voltage, they have some voltage drop when the train has a very big traction power. Otherwise, if the train break, the voltage will increase. So actually, due to we have very huge traction power, because we have very big acceleration speed, the voltage drop in the transmission line actually could be very big. But actually now we don't really have a standard for the voltage safe margin for the Hyperloop system. So I try to find some standard for the traditional railway system for different voltage level. So you can see we have different for DC electrification network as well for the AC network. They have different voltage safe margin definition. For us, we make a straighter standard for the voltage margin. We consider the voltage drop should be never past 10% of the nominal voltage, namely the voltage provided by the substation. Another important indicator is the peak power of the substation, because when a transport company or railway company, they build the contract with a DSO or TSO transmission system operator, actually besides they pay for the energy, they also need to pay for the peak power. Actually, if you can see the peak power profile, the tariff actually for 2023, for each megawatt, the society, they have to pay for around 50,000. But you see the evolution trend, actually the price increase per year. So obviously next year, maybe the price will continue increase. So actually the peak power provided by the substation is very important indicator from the economic perspective. So here we choose 3 cases for our test. The first test, we test for different substation installation position. And the second test, we choose the different substation voltage level. And for the case 3, we will test for different pod width and the launch frequency between launch delay time between 2 capsules. And just one note, when we see the position of substation, we choose the same direction as the acceleration direction. I mean, here is the total length of the launcher. When we can choose the 0.65 is the position of the substation. So here we test for 3 positions for the installation position for the substation. We can see we choose in the middle of the launcher zone and 0.65 L in the, and the last one is 0.85 L. Actually, compared to the result, here we can see it's the voltage profile of each capsule that is running in the transmission line. We can see the maximum voltage drop are different for different installation position. And for the case for around 0.65%, actually, they have the best performance. We have a maximum voltage drop around 5.8%. But for the other 2 cases, they arrive almost 10%. Now for another indicator for the peak power demand of the substation, we can see for different installation position for substation, the peak power demand also vary a bit. The same around 0.65 L, we have the smallest power demand. And another case study we do is test for the voltage level of the substation. And we keep 9 kilowatt and 15 kilowatt for the 2 tests. We can see if we choose the 9 kilowatt, actually the maximum voltage drop could arrive around 18%. actually has passed the standard we defined 10%. And for this one, if we choose 15 kilowatt, actually the voltage drop maximum arrive around 5.8%. And here is for the peak power demand for the 2 voltage level. You could see compared to the 9 kilowatt voltage level, actually the peak power demand reduced around 3 or 4 megawatt compared to the case for 9 kilowatt. This is easy to understand because due to the Ohm law, when we have the higher voltage, the power loss on the transmission line will be reduced, then the total power demand will reduce as well. The final test, the case study, is we test with different launch delay time between 2 capsules. The first one, we consider the most critical condition for the rush hour in the morning and evening peak. And we test another for 45 seconds. And this is for the freight pod test. They have a higher width, but the time delay is much larger. So compare these 3 cases, actually the maximum peak power could arrive around 40 megawatt for the time delay 30 seconds. And the power demand actually, you see they change periodically when they arrive the stable state. Then, I mean, even though we simulate 24 hours, actually all the process will be repeatable. So now we have analysis because we just talk. Actually, besides the energy, the transportation company or the railway company, the Hyperloop company, they will pay for the peak power. If, I mean, the peak power increase from 35 megawatt to 40 megawatt for the most critical condition, 30 seconds, actually they should pay around 250,000 franc per year. But as we know, actually the rush hour only happens from 7 to 8 a.m. and the 16 to 18 a.m. That means if we buy around 40 megawatts, actually around 80% of the day, actually they never reach the peak power 40. But we pay a lot of money for this part. This method, I mean, we increase the peak power for the contract with the Swiss grid. It's not very economical. So for conclusion, the first, based on our performance analysis from different case study, we could configure the position of the substation at around 65% of the whole length of the launcher length. And for the substation voltage level, we could configure 15 kilowatt. But I mean, because we just present with a higher voltage level, certainly we have the lower power loss and smaller voltage variation. But we couldn't choose the voltage as much as possible because we know firstly they will have a much higher requirement on the power electronics devices, on the generator, the machine, and also means a very much higher investment. So we choose a medium voltage to ensure the voltage safe margin and also balance trade-off between the economic investment. And then from the problem analysis, we can see because for our total power demand from the substation, it will have some different behavior according to the time delay between 2 capsule departing time, and also it also closely linked to the voltage level and the substation installation position. So if we fix the installation position as well as the voltage level, actually the most important factor is the capsule delay time between two of them. So we talk if we increase the peak power in the contract with the Swiss grid, actually we should pay a lot of money. So we would like to find another efficient solution to deal with the very high peak power. So in our next step, actually a Hyperloop microgrid concept will be studied to how to reduce the high peak power. And then if we integrate a high power storage module in the microgrid, we have to study the energy management system to deal with how to optimally reduce the peak power. And finally, a life cycle analysis should be conducted from the economic perspective. Besides, in parallel, we are doing a AC electrification system model with the Newton-Raphson load flow analysis method in order to provide a comparison with the built medium voltage DC system. Thank you.
Thank you very much, Pauline, for the talk. There are also a lot of questions from the audience, so we just jump straight to it.
Yes.
The first question to you would be, compared to high-speed rail, how do the peaks compare over a day? Have you looked into it? And how would you mitigate, let's say, this problem to make it more competitive?
Yes. Actually, in another project, we are also doing some like traditional railway network. Not very high speed, the normal speed. Actually, because for the normal train, they never depart in 30 seconds between two trains, maybe in half hour, maybe in 1 hour. Actually, they will not many trains are in the acceleration state in the same time. That means the power demand, because some trains are running in stable state, the traction power is much lower than the acceleration state. But for the Hyperloop case, actually, because the minimum delay time between two capsules, we are assume around 30 seconds. That means in a very, not around 3 kilometers, we have around 28 capsules on acceleration state. That means of quite a huge power demand for the substation. When compared to the case for the traditional railway substation, the power will much be lower. Maybe 10 megawatt, 20 megawatt. For the Hyperloop case I studied, it could be around 40 megawatts.
Okay, and does this have to do with the power tariff? Because we have seen that it decreased. Does it have to do maybe with the cost per megawatt of installation? Someone is asking if perhaps we're scaling up the system, this should be dropped by a percentage.
Sorry, I didn't understand your question. Could you repeat?
If this big increase has to do also with the power tariff, because we saw that it increased.
Yes.
So if it feels like if we would scale up the system, perhaps this pricing would go down.
Actually, I mean, for the peak power, we talk the payments are actually it's very high, and actually for the next step, we would like to find another direction to reduce the peak power. Actually, not change the contract with the distribution system operator or the TSO Swiss grid. Actually, we would like to use the storage module to reduce the peak. I mean, you could use the storage module to provide some the very peak part. And then in the much less peak period, we could charge the battery. So in the whole day, the peak could be reduced maybe on average 5 megawatts. So that's actually is more efficient and economical solution. We have do some actually we have done some research and some life cycle analysis. If around 5 years or 10 years, actually we could save much money regarding the investment for life cycle analysis.
Yeah, because this would be directly linked to the next question, which is if you have also done some research compared to other electrification models for Hyperloop systems, and what would be the strength of yours compared to the others?
Yeah, actually, because here I only present the part of medium voltage DC network. Regarding the AC part, I didn't present. In the project, we work with Eurotube. We did some simplified AC model. We found some simplified parameter to repeat the behavior for the AC case, because for AC case, besides the active power, we also have the reactive power, and we also have some synchronization issues to study. In parallel, actually, we are doing the, as we talk in the end, actually not really perspective because we are underdoing. We are building the AC model with the Newton-Raphson load for load analysis. Then we could provide a more complete comparison between these two models.
This would be then the next step to.
Yeah, exactly.
Yeah. For this, we then wish you lots of luck. I think also with this we finalize the Q&A session. With this, I would then hand over to Lucas. Thank you very much, Pauline, for tuning in.
Thank you.
Thank you. Just needed to find the unmute switch again. So next week we have a presentation from. Sorry, clicked too fast. We have a presentation from Lotte, who's telling us about the market potential of Hyperloop. Sadly, we don't have any second talk, but that's the talk for next week. And with that, that's all for today. And I'm looking forward to seeing you again next week. And maybe one thing that we can also announce still is that there's a special session coming up for the seminar that will be on Monday, specifically dedicated to EHW team members for their engineering towards their contributions for the EHW in 2024 in Zurich. So that will be coming up on Monday, the 27th at 18 o'clock Central European time. For everybody who wants to join in, we'll announce that next week again and on LinkedIn as well. So see you next week, Wednesday, and then we have some special sessions and the normal schedule coming up until the 6th of December. See you all next week.